Hello, welcome to our semiconductor education program. This is Vincent Chang. Today, I'm going to teach you the generation of triangular waveforms using Astable multivibrators. Okay, so first of all, I want to just reflect a little bit what we learned before from the past. So you have learned 3 lectures around the bistable multivibrators, right? Positive feedback loop, inverting configuration, and non-inverting bistable multivibrators. Okay, 3 lectures. And then you also learn another 3 lectures around the Astable multivibrators. Okay, square waveform generator. The first one is about operation of waveform, detail operation. The second one is about formulation. It's how to calculate the period, the frequency, etc. The last one is I show you a SPICE simulation example. But just picture the square waveform generator just in your mind. So how the square waveform generator was constructed? Inverting bistable multivibrator, right? With connecting an inverting bistable multivibrator with an RC. So now I'm going to show you another bistable, okay? Another bistable. So which is what? This is the inverting integrator, right? But followed by what? Followed by, this is the bistable, okay? But pay attention to the VO1 comes in, connect to the what? The positive terminal. It's the non-inverting configuration. So it's quite different, okay? It's quite different. So this becomes a triangular waveform, triangular wave generator. So bistable, the non-inverting. So let's start with the bistable. So because the nature of the positive feedback. So nature of the positive feedback. So only 2 choices. There are only 2 choices. So either high state or low state. Because it's the closed loop. It's the closed loop. So sometimes stay at high state. High state. Let's say duration is T1. The what high? The positive saturation voltage, V capital M. VO2, okay? So VO2 on the top. VO1, what do you mean by the VO1? VO1 is the output of the integrator. The VO2 is the output of the bistable multivibrators, okay? So only 2 choices, either high rest state or either low burst state. So high, low, high, low. Okay. So when you send a square waveform into an integrator, what would you see? A triangular wave, right? Because when you send a constant, the red constant, high to an integrator, that becomes the linear, first order. Because it's the inverting, so which means the linear is going to go up or go down. It's going to go down. It's going to go down because it's the inverting. So it's the inverting. So positive constant, negative slope. And negative blue, positive slope. Okay? Okay? Because it's the inverting integrator. So positive rest state, negative slope. And negative blue state, positive slope. Okay? So square waveform is so this kind of a nonlinear oscillator actually creates 2 types of waveform. If you take the output of the VO2, the second op amp, it gives you a square waveform. If you take the output of the first op amp, it gives you a triangular waveform, okay? So 1 body, 1 circuit, 2 function, okay? It depends on which output you are taking. So now, I want to stop for 5 minutes. Try to figure out the peak and the valley of the triangular wave, okay? Okay? Try to find out 2 question marks. So what's the value of the peak of the triangular wave? what's the value, the low point, the minimum value of the triangular wave. Okay, so let's pause for 5 minutes. It seems easy, but actually it's challenging. Okay, I won't say it's a little bit challenging. It's challenging. So if you didn't get this right, you can solve this, or it doesn't know how to get this. I think it's normal. Okay, for a beginner. Okay, so first of all, you got to be very familiar with this: the non-inverting bistable multivibrator. Okay, so it's not about how smart you are. Maybe it's a little bit. Maybe it depends on your intelligence or IQ, etc. But personally, I still believe practice make a big difference. Okay, so if you are familiar with this, you're confident. You have no problem. If you are not familiar with it, struggle with the counterclockwise, clockwise, then kind of you are in trouble. Okay, so non-inverting bistable multivibrator. Okay, so this is this, and you learned this before. Non-inverting bistable. So for the non-inverting, it's a little bit confusing. It's not a little bit confusing. It's quite confusing, right? To be honest, it's quite confusing. So the rest state, the high state, and the threshold is negative, VT negative. Red, red, blue, blue. Red, red, blue, blue. It's the counterclockwise. It's the counterclockwise. Okay, I won't belabor the detail. If you don't know what I'm talking about, including how to solve this upper threshold, how to solve this lower threshold, then you have to go back to the previous lecture around the bistable, the foundation. That's the foundational lecture. Bistable multivibrator. Okay, and this is the bistable on the second stage. First stage is the inverting integrator. It's the inverting integrator. So for the bistable, let's start with this. Let me just go back. This is the starting point. Okay? This is your ground, your foundation. You stand firm on your ground, and then that's where you can move forward. Okay? Otherwise, you just have to go back to study more. So now, let's move on with the solid understanding of what's going on with the non-inverting bistable. Assuming now VO is high state. One side of the hill, the right-hand side of the hill, stuck there. The VO is rest state, high state. Rest state, high state. Positive constant go to integration, then what? Then going, what? Going down. Who going down? VO1 going down. VO1 going down. So VO1 going down, look at the right-hand side of the slide. There's the arrow, right? And look at the left-hand side of the slide, there's also an arrow. Both arrow has the same meaning, okay? Color, also, you need to match the color. So when VO1 goes down, are you with me? Are you with me? Are you with me? For the right-hand side, the VO1 is horizontal, okay? That's called transfer characteristic. On your left-hand side, the VO1 is vertical axis. It's the waveform, all right? So you got to do the conversion, the translation, the transformation, okay? That's your job. But it's all very clear on the slide. So when VO1 goes down, VO1 goes down. When VO1 on your right-hand side of the slide goes down, then you look at the waveform. So when VO1 goes down, then compare with who? Who you compare with? red, because it's in the red. So compare with the red threshold, VT negative. Compare with the red threshold. Compare with the red. I strongly recommend, and this probably is going to be the final, okay? In the final, I will appreciate if you bring 2 pens, okay? 2 color pens, okay? Then I won't get confused, but you won't confuse either, okay? You can becomes very clear. Become very clear. So VT negative. As long as VO1 is higher than VT negative, the red threshold, this state can be remained, right? So until it reaches the VT negative, VT minus, then what? Then switch state, okay, right? Green, then green, green, then what? Who green? VO2, right? So VO2 counterclockwise. So VO2 go down. This is green. On your left hand side of the slide, VO2, green. You see? Is there any way we can make this more clear? I think I try my best. Okay? I try my best. I've done my best. With this, I think you should be able to do the match between the transfer characteristic and the waveform. And then what? Now, when you go to here, go to red state, you forgot, when you go to the blue state, you forget the red state. You forget the red threshold. You focus on the blue threshold. Right? So when you are at the low state, the blue state, then because it's a negative constant, through the integration, it becomes the go what? Go positive slope. So the VO1 start going up. You see the blue and the blue. And this blue, the right hand side of the slide, the blue, there's the arrow. And associated with the blue arrow on the left hand side of the slide, okay, has the same meaning. So when VO1 goes up, and then who you compare with? Because it's a blue. Blue state, you compare with the blue threshold. The blue threshold, the upper threshold, the VT positive, okay? So as long as the VO1 less than VT positive, this state can be remained. Okay, the low state can be remained. So until it touches the VT positive, which is the peak. Then what? Then brown, okay? Then brown goes up. Then brown, you just simply copy this brown to the waveform like this. You get it? So red counterclockwise, red, green, blue, brown. Red, green, blue, brown. You see the waveform, the VO2 waveform. Red, green, blue, and brown. That's hard. But with the help of color, the 4 color, then you can tackle this. All right? Get it? So what did you do with the 5-minute pause? I was asking you to solve. Here's the answer. Look at the slide. Okay? VT positive, VT negative is the maximum value and the minimum value of the triangular waveform. This. So it comes from the foundation of the bistable, non-inverting bistable multivibrator. I'm not going to repeat this. So here's the takeaway. Astable, okay? Inverting integrator followed by a bistable, non-inverting bistable forms a non-linear oscillator, an astable multivibrator. So 2 quasi-stable state. 2 quasi-stable state. High state, quasi-stable. Low state, quasi-stable. And red, green, blue, and brown. Let's do it again. Red state, compare with the VT negative. As long as it's above the VT negative, this state can temporarily remain. And then when VO2 is high, then VO1 goes what? Goes down because it's inverting. But when it touches the VT negative, such happens. Green, okay? Now VO is low state, and then you focus on the blue threshold. As long as it's below blue threshold, then this state can be remained. And then once it touches the VT positive, go back. It's challenging, and then through my lecture, it's not challenging anymore, right? But still, you can try this, okay? U.S. Navy study shows within 32 hours, you're going to forget 95% of what you heard. Okay, you can try to solve this after 3 days to see if you can still solve this. Again, familiarity gives you the confidence. So in the next lecture, I'm gonna formulate the detail, how to express the triangular wave frequency and the period, etc. So see you in the next one. Thanks for watching.